should mute myself. Here you go. Come on. Going live in a second. All right. Yeah, this is working. So we are getting close to 7 p.m., so it's fine. So preparing some stuff on here. Nicola, how are you doing?
Amazing. Amazing.
Yeah, you're still tweaking the mic. What mic do you have there?
It's a Rode anti-USB.
Looks fancy.
Yeah,
it's one of these USBs, isn't it?
Yeah, it's a USB, and I also don't have a pop filter. I just realized that. Traveling, this is not the best mic. Like, I really need something else. Yeah, this is too big, and the bag to transport it, it's not the greatest one. And also the pop filter that it comes with, it's a plastic pop filter. Yeah. So if you put it in the luggage, you might break it. So it's like,
okay, yeah. Let's say.
I need one of these mini mic for traveling, and this I have it installed at home on my beam arm, but now I need to mount it every time I go around. It's like, it's not great. Also, I'm using like a it's a camera. It's a Manfrotto, the smallest one, and with an adapter, because the Manfrotto is I think it's 1/4, and the mic is 3/8 of an inch. So they don't connect. You can't screw them. You need one of those crazy adapters on top. And it's like,
All right. So let's see. So we do have 4 people watching already. I would say we will start off. So the others can join afterwards and can catch up. So to everyone who didn't catch it, hi there. Welcome. And I'm happy you're all here. With me today is, I have to read it, sorry, Nicola Corti. I will never remember. Hi, Nicola.
Nice to meet you.
So we will have a talk about, we have one broken API among us. I think, Nicola, you told me that it will take roughly 30 minutes. So we will have enough time to have a short discussion afterwards. And if we don't, we have an early evening. It's also fine. Also, some kind of housekeeping up front. I will collect the questions and will make sure that you, Nicola, will get all the questions we get in the chat. So to everyone out there, feel free to pop your questions into the chat. I will collect it. I will give it to you afterwards, Nicola. And also, if you're still looking to publish your first Java or JVM or Kotlin related article, we are still looking for contributions on the javaadvent.com. I will put the link into the notes down there, and the links to all the presentations and code and everything Nicola will give us will be in the show notes as well down there somewhere. I will shut up now. The stage is yours, Nicola. Have fun, and I'm really looking forward to your talk.
Awesome. So I just need a second because I wanted to post the link on Twitter, so people, maybe we got some last minute attendee. 1 second. Yeah, and here. I hope you folks are safe at home and enjoying the time. And okay, so let me also close all the annoying thing.
I always forget this as well. So take your time.
Yeah, no, I don't want to have like notifications, other crazy stuff popping up in the meanwhile. Yes.
Oh, the word, what are you saying? Oh, all right. Okay, cool. Have fun.
So, are you able to see my screen? Amazing. Feel free to stop me if anything goes off. And yeah, that being said, thank you very much, folks, for being with us today. I'm going to talk about there is one broken API among us. And yeah, I posted this image on Twitter and it went really viral. Like a lot of people were interested just because I was making a joke with Among Us. And I know a lot of people now are like, blocked at home. And we're playing a lot of Among Us also at my company. So I hope you will enjoy the analogy that I will do during the talk. Mandatory slide about myself. I am a Kotlin Google developer expert. And in my daily work, I work as Android infrastructure engineer at Spotify in Stockholm, Sweden. Infra engineer means that I mostly develop tools and SDKs for other Android engineers. You can find me on Twitter as Cortinico and on GitHub as Cortinico. And this is my website. And I want to mention that I personally love to do a lot of open source. That's actually what drives me. And I have a lot of libraries and tools that I try to maintain. I am a maintainer of Detect. If you if you're into Kotlin, you probably know it. It's one of the static analyzer for Kotlin. And as part of my work and as part of my passion of open source, I happen to work with API. So my customer is either colleagues at work or people in the web that uses my library. So for me, having great API, it's crucial. And the problem is that doing mistakes is also really, really easy. So that's more or less the idea behind this talk. And just to make sure that we are all on the same page, I want to spend some seconds to tell who is this talk for? Like, who am I speaking to, hopefully? So if you are a library developer or a SDK developer, you will definitely get something out of this. If you're an open source developer, even more. Like, as I said, I happen to work with libraries and tools, and my number one priority is making sure that I don't break my consumer code. But if you're just an Android engineer and you don't do open source, like you do your stuff, or maybe you're a Java developer, and your idea is like, you know what, I have my Android app. I own the entire code base. I don't care about breaking changes. Like, I will do breaking changes and I will fix them. Yeah, you might think that this talk is maybe not relevant for you, but actually the mobile world is moving towards being way, way more modularized. So if you work in a mid to big sized application, we'll probably have like hundreds or thousands of Gradle modules in your setup. And one way to organize modules that I saw that is used a lot in the Android world is to have something like that. You have the app module, and inside you have a collection of feature module, and then you have like let's say the profile module. And inside the profile module, you maybe want to define like a module that is the API that contains the public API of profile, and then an implementation module that depends on API and actually provides the implementation for that API. This allows others that wants to use the profile feature to actually depend only on the API, while you can keep on developing the profile, touching only the code inside the implementation. This has a lot of benefits in the way that you can easily control how changes propagate inside your code base. It helps collaboration across different feature teams. And it's generally like a great way to organize your code base to make sure that it can grow. So if you're in such a world, you probably want to take care of your API. Like, you want to make sure that changes that you do to the API module don't break the majority of your code base. So today we're gonna talk about this, like, how can I see if there is one broken API? And I want to spend some minutes talking about what it means to be a good API citizen. So there are some techniques and methodologies that as developers we can follow to be a good API citizen. So to make sure that our API are easier to use and easier also to maintain. And I want to present some of those. So the first one might sound obvious, but remember to annotate with deprecate the API they're about to deprecate. and don't just delete methods, properties, or classes. This means, for example, that you have a function called replace with a parameter called with, and you want to remove this. The thing that you should do is actually to first deprecate, maybe also provide a message and explaining why this API is deprecated and what is the problem there. In Kotlin, you can also provide a replace with that instructs the IDE on which method should be used instead of this one. And also you can specify what is a deprecation level, being that either warning, error, or hidden. If you use hidden, you will basically have the effect of removing this method from the IDE, but you will not actually introduce binary incompatibility in your API. So another methodology that I suggest to use is the opt-in. So this is a feature that has been recently renamed. Previously, it was called experimental annotation, and it's an annotation to do something similar to what we are doing right now. Something similar to what I said before with the deprecated annotation. So it allows you to expose API that might be unstable or that you want to change in the future. For example, let's say that I have this function called getAnswer that returns 42. And I'm not sure if this function should be part of my stable API. I want to have the freedom to eventually change it in the future. The problem is that if I publish a library that contains this, people will start using it. And then if I want to remove it, I will have to deprecate, and it's a pain. So I can just annotate with my experimental API, a custom annotation. And then when I create the annotation, I need to annotate the annotation, which requires opt-in with a message. That special annotation will be used to define which method and classes are part of my experimental API. This means that when my customer wants to use this function, for example, to just print out what's the result, they will have to either propagate the API surface using, again, this annotation. This means that whoever uses this main function will also be subject to touching the experimental API. So again, they will have to apply this annotation, or they can use the opt-in annotation. This stops the propagation of the experimental API. This is a way that the developer has to say that they accept the risk of the experimental API, and whoever uses the main will not be warned, and they will not have to do like any extra annotation to use it. But here is where your customer accepts your contract and is okay taking the risk of using an API that might just be dropped at a certain point in future. So this allows you to remove this method without having to deprecate. And it's generally like a nice way to make sure that your API can evolve easily without so many constraints. Another methodology or technology that I invite to use is the Explicit API mode. Explicit API mode has been added in Kotlin 1.4, and you can enable that in your Gradle file or with a compiler flag. But the easiest is to use the Kotlin configuration block inside your Gradle. And you can enable that with either explicit API warning. That means enable explicit API mode in warning mode. So every violation will be reported as a warning, or you can use explicit API, and this will report all the violations as error. So what is actually doing explicit API? Explicit API is forcing your code to be explicit, and that's actually great for library and SDK maintainers. It means that, for example, if you have a class like this one, Checker Interceptor, and you enable explicit API without a warning, so as error, the compiler will warn you that this class has no visibility specified. So you need to intentionally say if this is public, if this is private, internal, or whatsoever. It's not only about visibility, actually. It's also about there are a lot of inspections that are part of explicit API. Another that I think it's worth to mention is the return type. So let's take this getAnswer method that we saw before. The return type here is not defined. And this is actually okay. Kotlin allows us to infer the return type. In this case, it's int because we're just returning 32. But if like you do a mistake and you accidentally add a .0 here, you're changing the return type. Changing the return type is actually a breaking change. Like whoever is using this getAnswer maybe is, I don't know, using that as a parameter for a function that expects an int or doing whatever. This is a breaking change. So explicit API mode forces you to define the type explicitly, and in this case will also force you to define the visibility of this function. Another methodology that I invite you to use is the semantic versioning. Semantic versioning means having a version that is composed of 3 fields. The first one is the major number that you are supposed to bump whenever you release a new version of your library that contains breaking changes compared to the previous version. Minor version, you are supposed to bump it whenever you release a new version that contains features and capabilities that are released in a backward compatible manner, so that it's backward compatible with the previous version. And patch, you are supposed to bump it only when you release bug fixes or patches to the current version. So there is this document called Semantic Versioning 2.0. It's translated in a lot of languages. It contains a lot of description on how you're supposed to use semantic versioning. And it has also a Bacchus-Naur form grammar for like how to properly specify semantic versioning. So this might be maybe a bit too much, like you don't really need to see the grammar to use it. But the reason why there is a grammar there and it's so structured is that there are a lot of tools out there actually that are able to understand semantic versioning and are able to help you to decide which version number you're supposed to bump. So this is all cool, but those are all methodologies that requires human intervention. Like you need to be smart in some way and understand what you're doing. The problem is that, I mean, yeah, humans are smart, but not always. Like we all do mistakes. And I personally did a lot of them. I released versions of apps and libraries that I thought like, oh, this is just a minor bump. And actually that contain breaking changes. So to protect us against those scenarios and to really understand what is the broken API among us, there are tools. There are automatic tools that could help us and can be included inside our build system to fully understand if you're doing a breaking change or not. And so today I'm going to present 2 of those tools. The first one is called Binary Compatibility Validator. So Binary Compatibility Validator is a first-party tool. So this is from JetBrains. It's inside a Kotlin org. And it's not so popular, but I think it's actually great. Like I saw the tool is evolving really fast. They keep on adding features on it. And I really invite you to take a look because if you're developing a Kotlin library, you will find it really useful. So how does it work? It's a Gradle plugin. So you just configure it in the classical way as you configure a Gradle plugin. A small note, unfortunately, the plugin is not released on Gradle portal. So if you want to use the plugin block, you will have to go inside your settings of Gradle and specify a rule on how to resolve the plugin ID. Otherwise, you can just use this other syntax, like the old build script way of applying plugin. But that's it. Like once you apply the plugin, it just works. If you want to go one step further, you can actually customize it. Like there are some capabilities that you can use of the plugin. And you can do that using the API validation lambda inside your build.gradle file. So the first thing is you might want to ignore some project. Like if you're releasing a library, generally you have the library module or the module that contains your logic. And then you have other modules that are like sample or test or whatsoever. And you're not interested in an API of those. Like, really, you don't care if your test class is, you're doing a breaking change there. Like, you're not publishing those. So you can ignore projects that you're not interested in analyzing with ignore projects. Then you can use ignore packages to ignore a certain group of packages. So from here on, I'm going to use a library called Chucker that I'm maintaining. And this library, we happen to have a package called internal. And whatever is inside the internal package, it's part of the, it's not part of the public API. So there might be public classes there, but you're not supposed to use them at all. There is like no, we don't enforce semantic versioning on those. So you use it at your own risk. And you can actually exclude those packages from the analysis that this tool is running from using this directive. And also you can use an annotation to exclude classes or part like functions whatsoever from your public API using an annotation like internal API annotation. This you just need to create it, and you can specify it with a non-public marker. So once you're done with your configuration, the normal workflow is like this. The first time you set it up, you're gonna run this Gradle task, API dump. So what is API dump doing? Is dumping your API. And the dump will end up inside a file called your module.api. And it looks more or less like this. So it looks kind of Java-ish, but it's not Java. And it's a representation of your public API. For example, like here we have a class, and this class is called Chucker and is inside the Chucker team Chucker API package. And like if you read through what's inside, it kind of makes sense. So for example, in this case, there is a field called instance of type Chucker. There is a method called dismiss notification that expects an Android context and is of type void. So this V here means void. There's another method called getLaunchIntent that expects a context and returns an intent. And then there is a function called isOP. And this has no parameter, and the return type is Z. Then in this case, Z means Boolean. That's it. And this is like, as I said, a dump of your API that you're gonna commit inside your repo. And then looking through the diff of this file, you will see how your API evolved. So how the normal workflow looks like. You commit this file, and then the next day you do a change. And when you do a change, you need to run this other task called API check. Or you can use the check task of Gradle. So if you don't know, check is a task that runs all the validation on your project. So like test, static analysis, detect, lint, whatsoever. So this Gradle plugin is smart in a way that connects the API check task as a dependency of check. So you can just run this task also as part of your CI. And what's the logic of this task? This task will recompute your API and we'll see if the API has not changed. So if the computed API file is the same as the one that is on disk, then the build is successful. There are no changes at all. If there are any change, then the build failed. If the build failed, you need to rerun API dump to do another dump of your API and commit that. This means that when you do a change to the API, inside the diff of your change, there will be a change to the .api file. So whoever is reviewing your changes will see that, and you will also see that. So let's see a couple of changes. For example, a non-breaking change. We add a new function to a class Chucker collector, and this function is a public function called clear of type void. If we run API check, it will fail because we actually changed the public API. So we need to run API dump, and we will see that the library.api file actually changed, and there is one new method called clear of type void. And this is a non-breaking change because we are just adding a method. We're not destroying our customer. A breaking change instead is something like this. Inside tracker collector, I have a property called show notification of type Boolean. This is a mutable property, so it was a var, and now I'm changing it to be a val. If I run API check, it will fail. And then I need to run API dump. And the change in the .api file is this. So the public final function set show notification method that expects a Boolean and return a void is gone. Why? Because this property actually creates getter and setter. And by changing the property to be from a mutable property to an immutable property, I'm actually removing one method, the setter. So if by any chance someone was using set show notification from Java or was calling .show notification equals something on Kotlin, we are going to break their code. So this is a breaking change. So the TLDR here is that this tool is helping you to understand if your API changes, but it's not helping you to understand if the change that you're doing is a breaking change or is a not breaking change. My rule of thumb here is if it contains red lines, if the diff contains a red lines, that means you either removed a line or you edited a line in your API, that's most likely going to be a breaking change. If it contains only green lines, like the example we saw before, because you're adding content to your public API, that's probably a non-breaking change. Let's see another tool that is a little bit smarter than this one, and that actually allows you to really understand if you're introducing a breaking change or not. And this tool is called JApiCmp. And this stands for Java API Compare. And the TLDR of this tool is comparison of two versions of a jar archive. So this is a community developed tool. And what it does, it just computes what's the API difference between two versions of a jar. And this comes as a CLI tool. So this is actually a Java tool that you can run from your CLI. So I added a slide on how to download it because I think it was not super trivial when I did it the first time. So it's distributed through Maven Central. So you need to go on searchmaven.org and search for JApiCmp. And then you will end up in a page that looks more or less like this one. This is the latest version. And then on downloads, you need to download the jar with dependencies. If you're not familiar with this is a fat jar. That means that this jar with dependencies contains all the dependencies you need, and you can just run it. If you download the jar, it will fail unless you provide all the dependencies in the class path. That is not really convenient. So my recommendation is really just download this jar with dependencies. And you can run it from your command line with java-jar. So java-jar and your file with dependencies. And the first thing you do when you actually run a CLI tool is you want to know, like, what are my options? So you will run it with -h. And there are a lot. There are a lot of options. I actually invite you to, like, if you're interested in doing this sort of analysis and understanding how your API changed, spend some minutes reading the help, because it gives you a lot of insights on what the capabilities of these tools are. The basic options that you need to use are -new to provide the path to the new version of the jar, and -old to provide a path to the old version. So you provide the two jars, and then this tool will compare them. There are actually a lot of other flags that allows you to modify how this tool should behave based on finding certain incompatibility, being that like a binary incompatible change, a source incompatible change, and so on. This is really convenient if you want to include this tool inside your CI. because based on those, the error code will change. So you can make the CI fail on certain circumstances as you prefer. So now I want to share with you a couple of commands that I personally use when I release libraries, and I think they can be useful if you never used this tool before. So as I said, you need to specify --old and --new. That's the basic. And one note here. So we are, like, this tool is designed to work with Java jars, like plain old Java archives, not with Android archives. So if you are developing an Android app or an Android library, you probably know that your library is distributed as a AAR. That is a little bit different than a jar. So what you need to do is actually compare what is inside a classes.jar that lives inside the Android archive. Like, this is important because otherwise this tool will just take the two Android archives and will tell you that there are no differences, because it starts to search for Java class files inside the Android archive that are known, and so it just tells you no differences. That's actually not true. You need to make sure that you compare the classes.jar that is inside the Android archive. Then I specify HTML file. I personally really like to see the HTML output because it's easy to navigate and to immediately understand what's going on. Otherwise, the tool by default prints the output on the console. And in our case, we happen to have a package that is the ComChecker TeamChecker API package. That is the package that contains our public API. So whatever is inside there is what we are extremely careful with, and what we expect people to use. If you have something like that, then you can include exclusively this package so that the tool will do this diff between classes that are inside this API package only. But if you don't have it, then you need to do something different. So you can invoke again. You need to make sure you pass this ignore missing classes, because probably you will interact with other classes, like from the Android SDK, from the other SDKs, and so JApiCmp will start to navigate also through those. So you need to prevent that with ignore missing classes. I personally also use --no -annotations. The reason behind this is that the Kotlin compiler adds an annotation on top of all the classes called Kotlin metadata that you don't want to analyze for the sake of the API surface. And in our case, we also have packages that we can exclude from the analysis, like the internal package. But if you don't have them, you just don't pass this exclude option. So once you run this, you would see an HTML report output. So if you open that index.html file, it will look more or less like this. Like, you have initially a report of all the things you passed by, and then you have the list of all the classes that have been changed. In this case, the tool with modified mentions if you actually changed the class, like if you added the code inside the class. Because binary incompatible changes and source incompatible changes are marked with the exclamation mark or with the asterisk. And like in this case, I just changed the checker interceptor class and I created a new one, the builder. Now I want to show you another report that is between library 3.2 and 3.4. So in this case, little side note, this tool also offers you like a guess on the semantic versioning. Like in this case, it tells you, hey, you need to bump the first number because you have breaking changes here. Yeah, and here we do have breaking changes. Like, you see that there is a lot of modified with the exclamation mark. And yeah, that's unfortunate. Now I'm gonna show you some of those. And for example, we have the API.checker class. And in this case, we have like this tool is marking with red this line, and it's saying that public static final field called of type string that was called log tag is removed. So what we did here, we actually removed a field that was public, and it should have never been public for whatever reason, but it was there. It was a logging field, and we just removed the visibility, reduced the visibility. So what I'm saying, I mean, the reason why I'm spending some minutes here on this line is that, like, I believe you should be strict with APIs and with semantic versioning, but also not so much. Like in this case, if you remove a login tag, you are not, like, your customer are not supposed to use that. So really, it's up to you. You can bump the major version if you're removing a field like this one. I personally will suggest not. The reality is that the difference between these two versions actually contain other more like critical changes. For example, in this class checker interceptor, it is one of the most critical classes of the entire library. There is one constructor that was removed. That's not great. Like, people that were relying on the constructor, maybe they just, like, they can't use it anymore. So why I'm telling you this, because it's actually reality. So yeah, there are people coming to you the day after you release a new version, and they will tell you, hey, this is, I don't know, I was using that method through reflection, and now it's just not there anymore. Or I'm doing swapping like one artifact with another, and it just doesn't, it crashes or whatsoever. So if you do library development and if you care about your library, make sure you take care also of your API and use tools like this one to have a look on what's going on. JApiCmp can actually be configured as a Gradle plugin. Like, you can integrate it inside your Gradle build. This is a little bit more tricky. I believe that this tool was not designed to work in a Gradle environment. Like, if you're using Gradle as your build system, please consider using binary compatibility validator rather than this one, because here there are a couple of drawbacks. So what should you do? First, you should use a Gradle plugin that is another Gradle plugin. Like, it's not the one from JApiCmp. It's someone that created a wrapper on top of it. And to do this, to run the tool, you need to create two configurations. So one is called latest, and another one is called baseline. With configurations, like, if you're not familiar with these, those are what Gradle offers you to specify dependencies, like implementation, API, compile only, and so on. So you create two new ones, and then you define two dependencies. The first one is of type baseline and is on your project library, like it's on the project. That's the baseline. And another one called latest, that is the latest version of the library released, in this case, version 3.4.0. And you want to compare those two. So you are using like a version that is on Maven Central against the version that you have locally in your Gradle build. You also need to make sure that you stop the transitive dependency resolution, because you don't want all the dependencies of like to be downloaded and to be accounted in the API diff. And then you can register a new task, call it however you want, JApiCmp, and then you can pass in the new class path those configurations. Like in the old, you will pass the latest, and in the new, you will pass the baseline. If you don't like the name, rename it as you wish, but you need two configurations to be able to compare them and to compute the differences. Then that's actually the power of the Gradle plugin. You can configure this task to map to all the configuration that JApiCmp offers. So for example, we can specify the HTML output file. You can say like if you fail on modification and so on. And you can mention like ignore missing classes or package includes. So yeah, amazing. Unfortunately for Android, it's a little bit more complicated because, as I said before, you can't compare the Android archive. This tool doesn't work with Android archive. So you need to get the classes.jar from the Android archive. So you will have to need a function like get.jar classes that I wrote here just for the sake of giving you an idea. But what this does, it will unzip the first file found in the configuration, and it will search for the classes.jar inside the dependency. So this is a little bit black magic, but I hope I gave you the feeling that this tool is great, but the Gradle integration is not as smooth as it could be. So now to recap. Like, we saw several tools today, and I hope I gave you the vibe on why is it important to take care of your API, and also how hard it is, because evolving APIs is not easy. And sometimes it feels like you're putting yourself inside a cage if you pick the wrong APIs, like if you make the wrong decision early on. On this front, I really invite you to take a look at this page. It's called Evolving Java-Based API 2. It's part 2 of another document called Evolving Java-Based API. This is coming from the Eclipse documentation. And like, when you work with APIs, it might sound easy to think what is a breaking change and what is not. But actually, there are a lot of edge cases. And in this document, you will find like a table with all the possible changes that you could do to an interface, and what happens if I add a static method, what happens if I add a default method or a delete a method, and so on, both for classes, like for all the possible API that you can have in Java. And it's really long. And you see that there are like specific, like a lot of nodes that tells you if that change is actually a breaking change or not. So take a look at those kind of things, because that will give you an idea of how you can evolve your API. And also use those tools. Those are great. Binary compatibility validator, to recap, is a safeguard for your API during your workflow. It's something you can integrate and work like and have constantly running when you're developing, so that every pull request that passes through, you can see what are the changes to the API surface. And it's also really easy to integrate. Really, like if you have a library, you can literally go there and install this tool in 4 lines and it will just work. It's not complicated. And I really invite you to take a look, specifically if you have Kotlin or Gradle project. JApiCmp gives you fine-grained control over your API surface. Like, it has way more options than the other, and is also really useful when making a new release. Like, I personally ended up using JApiCmp just before we go with a new version of Maven Central. Like, I just compute the differences between the two, and then I say like, oh yeah, that change was sort of expected, or oh my god, we removed a JVM overload from one class and method starts to disappear without us noticing. There are a lot of other tools that are similar to those. I personally, those are the two that I use more often, and I think they sort of give you a lot of help. And at the end of the day, please remember to be a good API citizen and use the techniques I mentioned today. So deprecate, expose experimental API, use semantic versioning, use explicit API mode, and use one of those 2 tools or others to protect your API. That being said, that's all for me. I'm more than happy to be here, and I hope you enjoyed the talk. You can find me on Twitter and GitHub as Cortinico, and I'm really eager to get your feedback and yeah, ideas, point of views. Thank you very much.
Perfect. So thank you so much. It was really great. So it looks like we do not have any questions so far. I would say if any questions come up, please send them via Twitter or put them on Kotlin Slack. And I'm pretty sure, Nicola, you will answer them all on time, right?
Absolutely.
I thought so. So, right. So thank you so much for being here. It was a real pleasure to have you on. Hopefully see you soon again. And to the rest of you, if there are no other questions, and the great talk, thank yous coming in already. Perfect. So enjoy your evenings, folks. As always, get in touch with us whenever you like on Kotlin Slack, via Twitter, you name it, meetup page, and we are happy to help out.